Hi everyone, welcome to today's live stream. Today I have a very special guest, David Eagleman, who's joining us from the west coast of the US. David, do you mind saying hi to everyone?
Hello there. Nice to meet everybody.
So seeing you live on screen, just across my laptop is a strange feeling because I watched your TED talk. That's 2015, right? Um,
Oh, yeah, that's
Yeah,
right.
when you and that was a fascinating talk, and you had this vest on, and then like it's just wowed everyone. So before I dive in, and we'll put a link to the talk there too, so people can follow up and then read and watch your talk back then. But Dave is a neuroscientist at Stanford and also a international bestseller and best-selling author, and he many of his books are on the bestseller list for periods of time, weeks after weeks. And today we have this pleasure and privilege because his new book, it was not that new anymore. It came out in 2000 called Livewired. Um,
2020. Sorry.
2020. Here you go. Sorry.
2020. Yes.
Yeah, yeah. But thanks for Cheers Publishing. The Chinese version is just becoming available in the China market. So that's why we have to most of us is still a new book. And of course, this book is among many bestseller books he has written on neuroscience or understanding our brain. And of course, also, I think your first book was actually Some, which is more a fiction book, right?
That's right.
Yeah, and we'll get to that a bit later because I'm very intrigued by your experience growing up and then your education journey as well, leading you to your all those fantastic things you're doing today. Also, he's a researcher himself. He has over 120 academic publications. He's also founder of two venture-backed companies that actually, make products based on the science and research he has been doing over decades. So all in all, a great pleasure and privilege to have you be able to speak to your future readers in China.
Great. Well, it's a pleasure to be here. I've visited China several times and really love it, and I can't wait to come back. So it's nice to have an opportunity to connect with readers there.
Wonderful. Yeah. So the Chinese translation of your book is actually an interesting one. It's called 粉红色的柔软的学习者, a pink-colored soft learner or soft-bodied learner, which of course is referring to the brain. But the English version is called Live Wired. And then can you maybe we start there, David? Why do you name it so? Why Live Wired? What does it mean?
So the book is about something called brain plasticity, which is the ability of the brain to adjust itself and um, reconfigure itself. It's rewriting its circuitry all the time. And so I wanted a word that was better than plasticity because that word actually comes from plastic, which is what we like about the material plastic is that you can mold it into a shape and then it holds on to that shape. But what's going on in the brain is so much richer than that, that what I wanted was a word that would represent something that is, 86 billion neurons all changing every second of your life. And so I came up with the word liveware, as in hardware and software. This is a different thing going on here. This is liveware, and I call what it does live wired. So that's how I got that title.
Oh, I see, I see. I guess that also explains the quote because you use this quote at the beginning of your book. Do you remember the quote?
Yeah, every man is born as thousands of men, but dies as one. And
Yeah.
what I loved about that quote, that's by Heidegger, the philosopher. What I loved about that is that's what brain plasticity is about. When you're born, you could be lots of different people, but depending on your experiences in the world, your brain wires up in different ways and you become someone different, such that by the time you die, that's the one person that you are.
Yeah. Yeah. Thank you. I think in a way, brain plasticity is not a new concept. I think many readers or listeners will know the rough idea, meaning like even till the day you die, your brain is still renewing itself. So in a way, that concept is reasonably widespread, I would say. So what's new in this book? Why do you feel you need to put a new book out, based on the brain plasticity sort of knowledge the public already have?
Yeah. Well, it turns out that the brain plasticity knowledge, I would say in general, there's a lot more happening in the literature, in the laboratories than is generally known. So let's, as an example, step back to the TED talk that I gave that you mentioned. Um, what that was about was that how the brain is locked in silence and darkness inside the skull, and it doesn't know what vision is or hearing or touch. It doesn't know what that is. Instead, all it gets are electrical signals, either because of photons captured at the eyes or air compression waves captured at the ear or pressure on the skin. All of that just gets turned into the same currency, which is electrical signals that go into the darkness of the brain. And one of the really stunning things that we have discovered, we being, the neuroscientists over the last century, is that you can feed in information to the brain via unusual channels, and the brain will just figure it out. So, for example, in 1969, there was a scientist named Paul Bach-y-Rita, and he put blind people into these chairs that had this thing that poked you in the back, a grid of little things that poked you, and he would set up a video camera, and whatever the camera was seeing, that's what you would feel poked into your back. So if I show a triangle, then you feel a triangle. If I show you a coffee cup, then you feel a coffee cup. And blind people got really good at being able to understand what was in front of the camera based on what they were feeling in their skin. And what this demonstrates is that it doesn't matter how it gets in there, as long as you push the information into the brain, it works to figure out what is out there. And so what I did in my laboratory is worked on this technique, which is called sensory substitution. I worked on this for people who are deaf. So we take audio information and we push it in through the skin. So what I showed in the talk was a vest that we had developed that has vibratory motors, these little bzz, 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 all over the vest. And it hears sound and turns the sound into patterns of vibration on the skin. And deaf people can come to understand the sounds of the world that way. And what we did then, I wish I had one here, but we shrunk it down to a wristband with vibratory motors on the wristband, and we're on wrists all over the world for people with hearing problems. Because we're capturing the sound at the wristband and turning it into patterns on the skin. And that information, climbs up the spinal cord and into the brain, and people can figure that out. So that's an example of brain plasticity that I think is not widely known. And we've been pioneering that for a while. In general, there are something like 30,000 new neuroscience papers coming out every month, which is an insane amount. And what I've done in this book is captured, tens of thousands of papers and distilled the principle, distilled like what is the big picture of what's being told to us here. That's why we need the book.
Yeah. Well, thank you. So I guess when I was reading your book, I was wondering because I studied biology in my undergrad. I remember that, of course, this is, years ago. You talk about different brains have different zones. I mean, brain have different zones. There's seems like there's a part for vision, there's a part for motor and all that. And then when I was reading your book and listening to your talk, it seems like that's not entirely true anymore. Is that right? Like, I think that's what your example is showing. Like, even if you lost the vision, your brain can somehow work itself to sort of substitute or rebuild a connection to visual signals. Is that part of what you're trying to get at by the renewed knowledge?
Yeah. So one thing that we've known for a long time is that, let's say somebody is born blind, this part of their brain in the back, which we normally think of as the visual cortex, is not visual because there's no information coming in through the eyes and connecting to there. So that part gets taken over by hearing, by touch, by memory, by other things. So that part gets taken over. Similarly, if a person is deaf, then this part is not the auditory cortex anymore. It gets taken over by other stuff. So um, the brain is very flexible. So when we see a diagram that says, here's vision, here's touch, here's hearing, that's just how it usually ends up if all of your peripheral devices are working. But if they're not working, the system is actually very fluid in what it can do and how it can change.
Yeah. Thank you. And also I want to go back to the numbers you just mentioned. You're talking about 30,000 papers a month. And then it just
Yeah.
like, almost impossible number of papers to catch up. And I think for most readers like myself, like you don't, even if you have the time, you probably don't have the capacity, or I don't have the capacity to digest all of it. I think that's why this is the value of the book. Like, there's somebody like David who's a researcher and sort of do the translation and synthesis or executive summary. So this,
Yeah. Yeah, that's exactly right. This is why I'm a big believer in popular science, because the idea, I've obviously spent my whole career doing nothing but this for, 10, 15 hours a day. And so then being able to say, look, here's what you need to know. That's why popular science books are so important. Yeah.
yeah. So thank you for doing the work. So for whoever listening, you can find the link to the book below because again, with that book, you take a condensed version or abstract version of all this body of research that has been done, and that's relevant to our life. So that's my
That's
second. Yeah, sorry,
Oh,
go ahead.
I was just going to say, and by the way, I think it really is meaningful to write it with, excitement as a story and mysteries. And, in other words, it's not just a list of facts, which I could do in a paper or something. Instead, it's written like a piece of literature. And I think that's what people have really enjoyed about the book so far.
Yeah, absolutely. And then with that, I want to refer to a little bit of your own background because if I read it correctly, you actually studied literature in undergraduate, right?
That's right.
And then from there, then when you went to Baylor College, that's when you started sort of advancing into science and neuroscience. And that seems to be at least an uncommon combination, starting as a literature major. And then you also studied in Oxford, if I was not
That's
mistaken.
right. That's right.
Yeah, and then
Yeah.
yeah, how did you sort of like if I kind of if I rewind the time back 30 years or so when you were back around the college time or graduate school time, how did you make those decisions of which path to choose?
Yeah. The truth is that my 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 father was a doctor and my mother was a biology teacher, and so I was always, I always knew about the brain and biology. But what happened is when I went to college, I studied lots of engineering and physics and space physics and things like that, but I couldn't quite find the thing that I loved. I don't know, mostly it was boring. And so, but I loved literature. I'd always loved literature. So I ended up majoring in that. But what happened is my last semester of college, I took a neuroscience class and it just blew my mind. And I thought, wow, this is the greatest thing I've ever taken. And so then I went to graduate school. I wish that more kids would take advantage of that sort of freedom or that sort of opportunity to study very different things, because I think it's really helpful. And it's certainly helped me as a lover of neuroscience and a lover of literature to be able to write popular science books in a way that people care about.
Yeah, thank you. I think David's first book that came out we mentioned earlier called Some, which is basically a collection of 40 stories of what happens after you die.
Yeah. And it's fiction, obviously, and
Right.
but they're short stories that are they're all mutually exclusive, which means if you believe any story, then the others can't be true. Anyway, it was a very interesting thought experiment, and that became, and I'm happy to say that became an international bestseller, and it got turned into two operas, and um,
Yeah.
and then Netflix optioned it, and so on. So it's been a lovely example for me of taking a scientific lens on something like, what are we doing here? And writing a book of fiction about that. And then it worked. Yeah.
Yeah, yeah. And then that book was translated to 33 languages too. I think it's also available in Chinese.
Yeah.
And that's why it's fascinating your own experience and you're starting, you know, a literature major and then taking a neuroscience course and then and becoming a researcher and then kind of in a way go back to the roots of storytelling
Yeah.
in putting those books out and then that has he made a huge impact. Um, and I wonder, like, because you talk about, of course, brain plasticity in the book. And I think if I did my calculation right, you're in your early 50s now.
Yeah, that's
Uh,
right.
and I'm in my, sort of late 40s. And then usually when people look at those age, would say, wow, sort of you're getting into the zone of aging, right?
Yeah.
But of course, looking at the level of productivity you have and then the different areas you're touching on, it's massive. Like, what are some of the learnings from the book that can be useful for commoners, like readers? Like, okay, I know brain is plastic. There are different areas of the brain that they can adapt themselves and rebuild themselves. Like, what are some things I can take away from the book if I'm not a researcher? Like, if I'm kind of marching into 40s, 50s, what do I take from
Yeah.
the book?
Yeah. Well, so the book is definitely not for researchers. It's for everybody, the general public. But I think there are many lessons there. One of them is that as we age, we go from having a very fluid intelligence. Like a child can be born anywhere on the planet and learn that language and learn what they need to know about their culture and their moment in time and all of that. But as you get older, the brain is less plastic um, because what we have is something that we call crystallized intelligence, which means the brain's job is to learn the rules of the world. And by the time you're our age, the good news is that your brain has really figured out how the world works. And you sort of know how people will react when you do things. And you sort of know how to do your job and how to use a computer and how to drive a car and whatever. Like, all these very complicated things. And that means that your brain doesn't have to change as much, which is both good news and bad news. The good news being your brain is successful. Your brain has figured out how to operate in this world. The bad news, of course, is that you're learning less. And if you start getting a disorder later in life, like a dementia, like Alzheimer's, it means that as the brain, physically degrades, you don't really have any backup there. But it turns out that if people age and they keep cognitively challenging themselves, they keep doing things that are hard, then what happens is even if they start having a dementia later where part of their brain is getting chewed up by the disease, it turns out they have what we call cognitive reserve, which means they're spending all this time building new roadways and new bridges, and they've got all this stuff that's happening there. So even as parts of it go down, they're still okay.
Mm.
So the single most important lesson that we have for aging is the importance of continuing to challenge your brain. And there are a million ways to do this. I would say the main thing is take on new tasks that are between frustrating but achievable. And and as soon as you get good at something, then drop that and take on a new task that you're not good at. That's the most important thing you can do for your brain, is continuously make sure that it has challenges.
I see. And then I guess for your case, like every day reading new paper is a challenge in its own, right?
Yeah, that's right. That's right. I've got plenty of new challenges. Yes. Yeah.
Yeah, so I think what in David's book there is actually this example of this from this nun, right? Like they decide to donate their brain samples after they die, and that's where this research is based on. That's fascinating. Can you share a little bit about that story for people who haven't read?
Sure. Yeah. So if anyone doesn't know, a nun is a Catholic woman who devotes her life to the church, and they live together in these houses called convents. And this is a study that's been running for a few decades, where all these nuns agreed that they would give up their brain when they died for research. So it turns out that the researchers were very surprised to discover that some of these nuns had Alzheimer's disease, but nobody knew it when they were alive. And the reason is exactly what I was saying. They lived till the day they died with all kinds of chores and responsibilities and challenges. And they were living with all these other people, which is, by the way, the hardest thing that the brain does is deal with other people, because you never know exactly what somebody's going to say and how, so they had very active lives cognitively, as opposed to people who retire and they have a shrinking social circle and they sit on the couch and watch television all day. The difference is that these people, if they start having brain degeneration, it becomes really obvious, whereas these nuns, it was not so obvious.
Yeah. Thank you for that example, because I found it fascinating, because when we often think about sort of brain challenge, we think about, okay, let's do a, crossword puzzle, let's play chess, or, let's play, or 象棋 in Chinese version of the chess. But basically that example is saying that it's not about, playing, cognitive games. It's actually about being in the community and go on with life in this naturally complicated way, right?
Yes. Yeah, that's perfect. You're exactly right. Getting together to play the games is not about the game. It's about all the conversations and friendships and whatever. Yes.
Right. It's the gossip, it's the difficulty.
Exactly, exactly.
So that's the power of community, because I think nothing is more
Yeah.
complicated than real life itself, right? So just don't retreat
Yes.
from life. So you
Yes.
can engage in life in the community that's lively, that's real, that's authentic. And that seems to be the best brain stimulator we can ever have.
That's exactly right. It's exactly right. And it's so important. I mean, everybody's looking at other things like, hey, should I eat, this vitamin or ginkgo biloba or whatever? But none of that stuff has very strong evidence to it. The main thing with strong evidence is keeping your brain active. Yep.
Yeah, thank you. I think if you take that one sentence out from this live stream, then that's worth $1 million. You can save on your supplement purchase.
That's right. Exactly.
All
Exactly.
right. So let's back up a bit on the brain development and earlier age, because lots of our listeners are parents, right? Of course, in Asia, I
Yeah.
mean, everywhere in the world, it's, education is a big deal. So of course, there are a lot of, attention on brain development in the early years. Earlier, we talked about the aging. And earlier years, as you started, like everybody start, the same, right? As the quote mentioned, like then what's critical in the first, like say 1,000 days? So that's usually a concept for early childhood. And what should, adults be aware of in developing younger brains?
Yeah. So that is the most important time for the development of a brain. What happened with humans is Mother Nature developed a new strategy, which is to drop the baby into the world half ready.
Right.
So it's like taking bread out of the oven when it's not quite baked yet. So as opposed to other animals like a horse or a crocodile or anything like that, they drop out. They sort of are, within 45 minutes, a horse can run. And same with a crocodile. And essentially all animals are like this, except for humans. Humans, we have these very long infancies, and it takes us a year to learn how to walk, and we're with our mothers for years and years, and so there's something very different. The different thing is we have extremely plastic brains, whereas most other animals do not. There's of course different degrees of plasticity, but humans are way up here. So the really important thing is that that is a gamble that Mother Nature is taking, and it usually works. And the human species has been so successful, and we've taken over the whole planet, and we've gotten off the planet, and so on. But it's critical that a child receives love and language and touch. These are all things that Mother Nature assumes will happen for the development of the child. And we have these very tragic cases that are very rare, but where a child is so neglected that they don't get any language or touch or love. And what happens is their brains do not develop correctly. They can't function in the world. They never learn language. They don't have the proper interaction with other humans. So we need that in order to wire up. So, I have two kids. Being a parent can be really frustrating when you have little infants. They require a lot of work, but that's the key. Talk to them, hold them, love on them. That's really important for the development of their brain.
Yeah, thank you. No, indeed, there are a lot of research actually in China as well, because in China there's a phenomenon called life behind children. When the parents, basically become migrant workers, go to the
Mhm.
city, where babies were left with their grandparents, and usually grandparents would say, "Well, you don't understand anything, so why do I talk to you?"
Right.
So they were left, basically unattended to, other than being physically attended to. And that there are massive research there as well, just saying by the time they reach 1,000 days or 3 years old, there's a huge gap in terms of developmental stage compared to babies who are normal. So thank you for that. That indeed. So if you have younger children or younger babies or toddlers up to 3 years old, basically that's what, time and time again, what brain research has shown. You have to give them enough stimulation, hugging, touching, talking to them, rocking them. Although they
Yeah.
can't respond, but their brain is, right? Their
Yeah.
brains are responding very actively.
Exactly. And it turns out that for a baby's brain, it starts off, you have 86 billion neurons, the cells of the brain, and they're not that highly connected with each other. But over the first few months, they start making more and more connections. And by the time the baby is 2 years old, you have about 15,000 connections per neuron. And
Yeah.
um, and it turns out that after 2 years old, then what happens is you start pruning the garden. You start cutting connections away, such that, for an adult, you have about 10,000 connections per neuron. So, the first few years, that's when everything is happening, and the baby's brain is saying, okay, what world am I in? What language do I speak? What is my, culture, my religion, my whatever, all that stuff is getting laid down in the first few years. Yeah. And
Yeah.
and it turns out, by the way, if a child does not learn language in the first few years, they cannot learn it. Their brain is
Mm.
unable to learn it because all through development, you have closing doors at different times. Doors close and things become too late. And language is one of those. Yeah.
Yeah, yeah, thank you. By the way, if you're enjoying this talk, you can actually find all this fascinating information, stories, and all the scientific research behind it in the book. The book has 12 chapters,
Yep.
and each chapter is such a joy to read. And I love how you named each of the chapter as well. And I think the Chinese version did a good job of, although it doesn't, translate directly. So for example, chapter two, the chapter one is basically, where the Chinese name of your book was taken, the delicate pink. Is it magisterium? What's the right way to
Yeah.
pronounce
Yeah. Magisterium. Yeah.
magisterium? So basically that's the Chinese version called 粉红的柔软的学习者. And then basically talking about the foundations of the brain, or the physicals, and then how, the mechanism, how it function. And then the second one is called just add world instead of just add water. And then just saying like that's how brain develop, because exactly as what Dave said, you kind of you all of us were born kind of half baked. You have all the components, but there is like the world has to be added for the brain to develop. So in a way, the brain isn't sort of born. Like you're not born with such brain. Yes, you're born with probably half the brain, I mean, to be scientifically inaccurate. But it's the interactions that shape who you are. Is that a fair way to say?
That is exactly right. And that's, yeah, like I said, that, what that allows us to do is each human brain that's born gets to figure out their world and then springboard off that to do something new, as opposed to, I mentioned, alligators or horses. They're living the same life that they've been doing for millions of years. There's nothing different if you compared us to alligators 30,000 years ago, but humans, it's like a whole different story. And that's because each of us starts where the last generation left off. And
Hmm.
that's what has made our species so successful is our ability to say, okay, what were all the lessons that were learned? Okay, great. Now I got it. I'm going to do something new.
Yeah, yeah. And then I think now we covered sort of a bit of aging part, we covered the beginning, and then let's talk about sort of in the middle. That's where sort of, the massive things happen. And I love how you use this analogy of city, right? So you're comparing a brain to a city or to a metropolitan or whatever that one. Like, can you explain why? Like, why is brain similar to a city?
Yeah, there are lots of ways. I use this analogy all the time because, first of all, to think about the brain is very, it's a huge, complex interacting system. So, just as an example, people will often say to me, "Hey, what area does this take place in the brain? Like generosity or, sense of humor or whatever?" And the answer is, it would be like looking at the city of Shanghai and saying, "Hey, can you point to where the economy is?" You can't because the economy is every interaction happening across the entire city. So it's the same thing in the brain. It's a big, complicated system. But there are several analogies that I use that have to do with brain plasticity. One of them is the way that what happens to you when you're young really matters because that's what lays down all the original roadways. And then as cities, as brains develop past that, they can never really get rid of the original roadways. So if you look at a city like Rome, it has these, very windy little roads. And that's because those all started as footpaths, marching soldiers and whatever, thousands of years ago. But if you look at a city like Shanghai, then you've got, grid work because, it's a more modern city. But the point is, if you look at so the point is that the roadways in Rome got laid down, and even now, when you're building internet cafes or high tech companies, they still have to deal with the fact that the roads are a certain way. Even in Shanghai, if you look at pictures from, let's say, 100 years ago compared to right now, like if you see some shot from a hot air balloon or something, what you see is that the city looks the same. It's just very modern now, but all the original roadways are the same. Anyway, the point is, this is why it's important to have children have good experiences, because the roads they lay down when they're young stick with them their whole lives.
Yeah, yeah. And I love that analogy about economy because so economy, when I was reading, it feels like because you, of course, also did an excellent job explaining how brain works. It's like everything, the external stimuli was translated into basically electromagnetic signals, right? Doesn't matter if it's a sound or it's color. In the
Yeah.
brain, that's what it is. So the physical sort of foundation seems to be simple, or just like in the city, well, it's just a building, right? So you find a building in Shanghai, you find a building in Chicago, you find a building in New York, you also find a building, somewhere in Africa. But the economy is those interactions, or just like those electromagnetic signals,
Yeah.
right? So it might be the same bundle of cells, but the signal transmission pattern can be very different, and therefore the quality of the economy or the nature of the economy can be very different. So I really like that abstract, but also at the same time very visual way of understanding how that
Good,
works.
good.
Yeah, yeah,
Yes.
yeah.
Yeah, I
Wonderful.
love. Yeah, I use a lot of analogies in the book, as you've seen. Um, and I find these very helpful. I mean, sometimes I talk about the brain like a globe
Mm,
because what happens is, you have all these changes in the globe of the earth, like all the plates are shifting and continents are moving very slowly. But then you also have things that happen really fast. Like if there's an earthquake, you get bigger changes. And then you have at very small levels things changing all the time, and you get country borders changing, and this country is here and there and moving. And so all of these things are sort of like the way that a brain develops through a lifetime, which is to say that most changes are slow, but sometimes there are fast things that happen.
yeah,
Yeah. So
yeah. And I want to go back to your talk in 2015. Again, when I was watching it, I was shocked. It's like almost 10 years ago. It feels very current.
thank
Oh,
you.
and then Because in the book, in the talk, you mentioned this fact. It's very interesting. You start, for those of you who haven't watched it, of course, we'll share the link. You can see yourself. But you started with what is reality, right? So we see, there's a lot of proverbs saying, okay, what you see with your eyes are reality. But that's not necessarily true because our eyes are very constrained to just the visible range of the entire
Yeah.
wavelength, right? So we can see UV light, we can see, ultra right, and then that's even a smaller version. So like then it's very philosophical in terms of like what is real. Like so it's only real in the way you're able to receive, because we're
Yeah.
constrained by our receptors. And so it's true with sound, right? So we can only hear this, sort of bandwidth of, wavelength of sound. It's the same thing. And then I think that's why in that talk it's so fascinating. You talk about if we know that some part of ourselves is impaired, we can actually restore it. Like it's already real technology, restore hearing, restore vision with implants and retinal implants. But that gave me an interesting, like almost question, like everybody probably have it. Like, well, then if we can restore it or we can do an implant, can we do one with a wider range? So
Yes.
that becomes supernatural. Like sort of almost sci-fi movie comes true, right? So like then I wonder since then till now, it's almost 100 years. I mean, almost 10 years. Like, what are the advances in that aspect, in playing with
Yeah.
expanding our reception?
Yeah, yeah. I've been very interested. I've written a bunch of papers on this in the last few years. It's what I call sensory addition or sensory expansion. And the idea is, yeah, could you, other than the little bits of, little bandwidth of wavelengths that you can pull in with your eyes or your ears, could you do something broader? And we have done that. So, for example, one of my favorite applications is to see in infrared light. And so that tells you about heat, which you can't see, but you can see in infrared. So, for example, I wear the wristband, and the wristband is picking up on infrared light. And I'm walking around, for example, if I'm walking through a parking lot, I can feel as I'm passing the cars, I know which cars have been parked there for a while versus which cars have pulled in the last half hour because the engine is still hot. And I can feel that as I'm walking past that. And then let's say I come into the library and I see two empty chairs. I can tell which chair has been sat in the last half hour because there's still a heat signature on the chair. And I can even tell which books have been selected because when someone's holding a book, there's still a heat signature on it. So it's like being able to see all this stuff that's totally out of our perception normally. So I really love this. I'll give you an example in the sound domain. There's a guy in Africa who studies insects that chirp at 35,000 cycles per second, and we can only hear up to about 20,000 at most. So he wanted to set it so that it would hear these insects. So we just set the thing for him, and he can walk through the forest and hear where these guys are, and it just becomes, it's just like expanding your ears. So there's so many ways that we can expand this stuff. I've been very interested in, you know, pulling in data, let's say from the internet, stock market data or social media data, and feeling some sort of summary of that on your skin and having that become part of your perceptual reality.
Yeah.
Um, the thing I'll just mention is that our eyes are overtaxed. We have way too much, stuff that you have to look at and see to deal with the world. So it doesn't really make sense to do, augmented reality glasses where you're layering even more stuff on. But our skin is generally not really used for much of anything. And so we can push a lot of information in through the skin that way.
Yeah.
Yeah.
That's fascinating. And I think the other side of it, the flip side of it, of course, is for people who are missing it, right? So
Yeah.
if you're deaf, you're blind, then of course this become a lifesaver. And then that's why your talk back then got this standing ovation because people, like and then was just really impressed and inspired by what you do for the blind. I'm actually curious myself, like has that product been wider, like what widely used now by this community?
Yeah, yeah, exactly. We, so many deaf people, mostly in America, um, use it, every day of their lives. They're wearing this, that's their new ears. Instead of
Yeah.
picking up information here, they're just picking it up through their skin, and that's what allows them to hear what's happening, a baby crying, a dog barking, a car honking, anything like that. Yeah.
Yeah. Wow. Thank you. And that's where you see science really impacting uh,
Yes.
the
Yeah,
real world
yeah,
lives.
that's why I spun this off as a company because I wanted to build a product that people could use. And now, we have, as I mentioned, we have tens of thousands of people who use this product every day.
Yeah, thank you. And then the next question I have is intrigued by a dialogue I watched you do with Sadhguru.
Mm.
I think that's probably a few years ago. And then it was so interesting. He went to explain it was like 13 or 20 layers of brain or like our cognitive layers. And then of course you on the other hand is a brain scientist. It's very fascinating. And I think now during especially after COVID, I think a lot more inward look, for us as a race. I think people start to, to understand impermanence, to understand, things would just, change, like, suddenly. And it has a
Yeah.
lot more reflection on life and also kind of tapping into sort of the broader wisdom we have other than just the cognitive layer of brain. Yeah, I wonder what do you have to share with our audience on that? Like, understanding the brain seems a very, in a way, a hardcore science kind of, topic, right? But of course, this is also where all the wisdom is housed as well. I mean, at least that's the
Exactly
material piece
right.
of it.
Yeah,
Yeah.
that's exactly right. I mean, look, wisdom is just pattern recognition through time. So a child can't have wisdom, but as you get older and older and you've seen situations, you've seen lots of versions of things, you start to extract deeper and deeper lessons. And that's why we tend to respect our elders because we realize, wow, this person has seen a lot and they kind of get this at a level that I don't. And that's what wisdom is about. And yeah, as far as impermanence goes, what's interesting about that is the brain really is always trying to make a model of the world. Remember, the brain is locked in darkness there, and it's trying to model what's going on in the world and what the rules are and how to understand it. And the brain really wants permanence. And when things change, that makes the brain very anxious and nervous. And so, and it has to pay attention and try to incorporate a new model, a better model, and then say, okay, now I got it. Now I understand the world. And then it changes again, and it's really hard. And that's why things are tough. Every time somebody dies who or things change, or you lose a job, or there's a new, whatever. It's hard on the brain, and this causes a lot of people causes a lot of stress and anxiety. And we all saw that in 2020 with the pandemic, or 2019 for you guys. It started a little earlier. And it was really hard on people. Suddenly you had to live at home and, be locked down, and nobody was happy about that. Um, so there's a funny thing with the brain, which is it's always trying to balance between familiarity and novelty. And it's always trying to find a sweet spot in the middle. And if things are too novel and everything's not as you expected, then the brain doesn't like that.
Yeah, yeah. And then now, when I was reading the book, there was also interesting sort of sound, almost like your voice in my mind, and talking about, if I were an AI scientist reading your book, I want to take that into then put into basically that's sort of a artificial neural network, right?
Yeah.
And then that now, I mean, when the book came out, that was before ChatGPT. Of course, when your talk came out, that was before that as well. And then in this past year and a half or so, there's so much development, artificial intelligence that gave people a sense of like our brains becoming obsolete, right? So this physical brain is obsolete compared to, this massive like machine that knows like everything. Yeah, what's your take on that? I'm curious, like, as a brain scientist, and what's your take on
Yeah.
ChatGPT and how we should, interact with it?
Yeah. I mean, it's been just an amazing couple of years seeing this AI finally achieve its promise. But the thing to keep in mind is that ChatGPT is a statistical parrot, which means, it's absorbing everything that's ever been written, and then it's making decisions about what word should go next. Given all these words, what's the probability of the next word? And that's all it does. It doesn't understand anything that it writes. Now, it comes off as very amazing and smart and so on, but it doesn't actually have any smarts. It's just putting words in a good order. And so that's the difference. And by the way, AI will get there at some point, but right now it's not doing what the human brain does. So, a 4-year-old child can navigate a complicated, space and manipulate adults and put food in her mouth and do all kinds of things that a child does. But AI is really bad at a lot of this sort of stuff because it doesn't have a model. Let me just give you an example. If I were to say, hey, when David Eagleman comes in a room, do his eyebrows come with him? It wouldn't have any idea because it doesn't know that, because it has no physical model of the world. And so, but of course, it's trivial for a child. And what's interesting, I'm actually writing an article about this right now. What's interesting is that some kinds of questions that people ask, they're amazed that ChatGPT gives the right answer. It seems very sophisticated, but that is just an echo of what it has already absorbed. In other words, someone else has, written about this thing at length. And so somebody asks the question and gets the right answer, and they think, wow, that thing's really intelligent, but it's not intelligent. It's just that somebody has written about that before. So one has to be very careful how you judge whether it's intelligent.
Yeah, but what if I think it's a very mixed feeling now, and then there's some of the readers have the sense of excitement. Of course, they will, probably replace a lot of, repetitive works we do,
Yes.
and then there's also this, sense of anxiety and fear, so to speak, because it seems like it's developing massively, right? So like, it's at a speed that's faster, at least faster than the biological speed we are used to ourselves. What are some of the, like, especially for the group who are anxious, what are some your advice to them? Like, what should they think about this issue, and what should they do?
Yeah. Well, I mean, the truth is that, the truth is we are in a fast changing world right now. Things are going to get really turned upside down with the economy. It used to be, especially in a country as old as China, for, hundreds or thousands of years at a time, things were not changing that much. But now suddenly, every 10, 20 years, life is quite different. You and I are old enough to remember life before the internet. And if you had told us when we were children that there was going to be, this thing, I mean, it would have been impossible to even imagine. Or the idea that we're carrying around these rectangles in our pockets that have the entirety of humankind's knowledge on them. So things are changing fast, and there's nothing anyone can do about that, except to try to figure out, okay, what are the jobs going to look like in 10 years? One of the places I find this important to think about is with education, because it really doesn't make sense to teach children particular ways of doing things now when the jobs that exist in 10 or 20 years are going to be totally different. And by the way, this is not a new challenge. I mean, when pocket calculators first came out, teachers had to think about this. Should we train kids for hours to do long division by hand, or does it not really matter anymore? Or even, I don't know, 25 or 30 years ago when personal computers ended up everywhere, then the question was, do we have to teach children calligraphy? Or maybe it's not as important anymore because you can just do that online and have it look beautiful. So we're again facing this moment in education of saying, look, does it make sense to sit down and write a whole essay from the first word to the last word? Or are there other ways of getting that done that might be useful? Here's what I think about it. I don't think it's going to be so bad necessarily, and I'll tell you why. When the printing press was invented in 1440, a lot of people panicked about that, and they thought, the next generation is going to be so stupid because there's no reason for them to memorize the answer. They can just pull a book off the shelf and there's the answer. And so they were very worried about what would become of the next generation. But in fact, the next generation became even smarter and even smarter because now you don't have to memorize everything. You just have to know where to get it. And now the getting of it is easier than ever. And so that's really good news. And so I'm very optimistic about the future. The last thing I'll say about that from a plasticity point of view is that what children are getting now is a much broader diet of information, right? So even when we grew up, you just had, you looked in the encyclopedia or whatever, and, you had the books you had. But kids now can learn so much about anything that captures their interest or their curiosity. They can find that information. And that's great from the point of view of brain plasticity. That's so great because kids can get the information in the context of their curiosity. In other words, as soon as they care about something, they get the answer. And that turns out to be really important for brain plasticity. You need to be able to, get the information right when you're curious about it. Whereas we grew up with being taught lots of information just in case we ever needed to know it. So I think the next generation is going to be even smarter, and they won't have to waste, a week writing an essay if they can shape it in other ways and do it much faster.
Thank you. So in David's book, there are quite a few chapters on learning and education. I think that was is it chapter 10 and 11? And of course, all of your chapters in a way touches it, but they talk about how learning happens and how memory works. And again, do get a copy of the book, and you will find a lot of both interesting stories and scientific research basis for lots of that. And then thank you for that comforting one. So the last few minutes, I'll have let's kind of focus on a smaller question. You mentioned you have 2 kids. I have 3 kids myself. And of course, at this age, as you said, I feel the same. I feel it's fortunate that they can learn so differently from how I learned. But there is when I was reading your book, I also think it's so interesting because everybody go back to like my pattern is the best pattern. And that's kind of how brain works, right? So like, the way I learned, like the way I was taught, I was educated, the old days were the best. But of course, reading the brain, that's basically how our brain, I love what you said. I want to pick that moment. You said our brain actually constantly try to be okay, right? Try to fit into the world and then be reassuring. Oh, you're fine. You're fine. Your model was a good model.
Yes, exactly.
But now, like as both a father and a brain researcher, popular science advocate, like what are some things you do with your children that, kind of incorporate your research and your reading, and you feel that you believe can, prepare them better for their future?
Yeah. Well, one thing is I always try to be very tech forward, which just means, making sure they're getting introduced to these things. I mean, I introduced my son to ChatGPT a couple of years ago, and then he ended up, writing an essay using ChatGPT about why children should be able to play video games. And it was great. It was, he was like making an argument and using that as a tool. And that was useful.
How old was he when
he was 10. He was 10 when he did that.
Yeah.
But yeah, I mean, the general thing is, supporting them to get as much information as they can, meaning, sometimes that's getting them off of computers and taking them out on a hike and talking about, the trees and the rocks and everything else. But sometimes that's letting them be on computers. I'll give you an example of something that I think is amazing. My son just showed me this thing that he has in virtual reality, which is for playing a piano. So what you do is you sit in front of the real piano and you put on the VR glasses and you align the virtual keyboard to the real keyboard. And then you choose the song you want to play, and then you see these lines coming down and the key lights up, right? So it's like these videos that we've seen for years, but this is in VR where you're actually just hitting the real piano at the right time. And it's such a good way to learn. As soon as I saw that, I thought, oh, why haven't we always been doing that instead of, you read a staff of music and you look at the notes. It's such a terrible way to do it. So as we develop better and better technologies, we will keep unlocking these better ways for children to learn. And what that means is that he can get good at a song much faster, which means he doesn't need the VR and can play the song himself, which means he can manipulate the song and try to change things about it. And he can just speed that whole process up. Instead of taking 5 years to become a piano player, he can do it in, 5 months. So I'm very enthusiastic about using new technologies in ways that improve learning.
So tech forward, that's
Tech
basically.
forward, yes.
Yeah, yeah. Anything else? Are you worried
No,
sometimes you're addicted to video
oh,
games? Yeah.
right. Actually, that is a worry. I mean, the truth is, as we all know, video games are so amazing now, totally different from when I grew up. They're so immersive and amazing that it's really hard. I noticed this with my 12-year-old boy that, it's often better than anything else in the outside world. So I think as parents, we just have to do the right sort of, constraints on how much time they can spend and then force them off of that. So obviously, it's a cat and mouse game. And the latest thing is, I can control their network so I can turn off when they have Wi-Fi access, stuff like that. So that's the careful dance that the parents have to do nowadays.
Yeah, yeah, yeah. And I think that also goes back to the earlier thing you mentioned in terms of if we look at from the brain perspective, the brain needs stimulation, need new way of learning, but also need, as you said, healthy dose of community interactions, friends, and
Yes.
of course, nature and everything. That's by even evolutionary design, right? So kind
Yeah.
of putting that all together is sort of the health recipe for the brain. Um,
Yes.
is that right?
Agreed. Yep. Agreed. Agreed.
All right, wonderful. Thank you so much, David. And then again, as I said, you can find the link to the book. The Chinese version is very well done by Cheers. And then with a lot of interesting stories and illustrations. And there are a lot of interesting graphs which we can capture in an interview like this, but you can find it in the book. And of course, a lot of I would say inspirations and on how we conduct our life, how we, deal with our own aging problem, and how do we, support our children in this new
Yeah.
era. And thank you so much, David, for putting
Great.
this. Yeah,
Thank you so much for this lovely interview. I loved being here. Thank you.
thank you.